How to arc weld. Well, this video is at least going to be basic enough to get you started, because there's a lot of stuff to learn when you're arc welding for all position and different kinds of metals and stuff like that. First, use a full face shield so the electromagnetic radiation coming off the light from welding doesn't burn the hell out of your face and ruin your eyes. And use a dark light filter like a number 10, darkened screen glass. The most common welder for an everyday type of welder, using in a garage or just general fabrication, or a backyard mechanic like me, is an AC 220 volt, 250 amp output, electric welder. It has no selection for using with DC, which is special rods for more exotic kind of welding. They're kind of cheap too. They range anywhere from $250 to about $400 brand new. And they're really simple to wire up. You can just wire them up to a circuit for like a stove or something that uses 40 amps on 115 volts each wire. So you can adjust how many amps output they have either by cranking a lever or moving up and down a lever. Either way works just as well. And the rule of thumb is, for every thousandth of an inch thick your rod is, like for example a 1/8 inch thick rod is 125 thousandths, it would likely work best welding around 125 amps. If you want to weld with a 1/4 inch welding rod, well then you'll need close to 250 amps, but maybe only 225 amps if that's all your welder's got. These welders are good for welding steel, usually at more than 3/16 of an inch thick, because they're very powerful and they don't seem to arc very well at amperage less than 100. There's a 1/8 inch rod, and there's a 1/16 inch rod, or maybe it's 3/32, could be a little bit more. Now if you have one of those 115 volt welders that puts out only about 75 amps or so, they're really hard to work with. It's really hard to get arcs going on these skinny rods, but very easy on these larger rods at 1/8 of an inch diameter or more. To use these tiny rods, you almost have to already be an expert in using the other type of larger machine, just because they're so hard to weld with. They just don't want to carry the spark. These electric AC welders produce a lot of heat with welding, and they have a very good penetration for doing structural welding or fabrication. Always too much penetration if you're using them on thin metals, and they're absolutely useless trying to weld cars, unless you're doing the frame. If you wanted to make a strong weld with a thicker piece of metal with one of these, you would grind a 45-degree chamfer all the way along the edge of both pieces that you're going to weld together, so that you're dropping your weld blob into a V. So you'd have like a V all the way along these two surfaces. That would give you good penetration on the other side and a larger surface area for the weld to attach to on both chunks. If you want to do a weld to a part that's going to be held 90 degrees to the other one, you would put a couple little tack welds on each side, because when you weld and the weld starts to cool, it's going to suck the part right over to a position you don't want it to be, and the tack welds prevent that from happening, or at least prevent most of it from happening. When you're doing a 90-degree weld like this, you don't need to do any grinding or chamfering. You just run your bead along there and also tack the other side so it doesn't bend over when it cools. Luckily, these kind of welders are less sensitive to slag, or the coating that's on hot rolled metal, or to rust, compared to MIG welders. MIG welders just hate welding to any foreign material because it releases a bit of oxygen. The disadvantage of these welders is that they produce a flux coating on top of your weld called slag, and if you're not doing a good job welding, you get slag inclusions in your weld, which is like little pockets of flux, which weakens your weld. When you're done welding with one of these welders and you've got a bead of weld, it's going to be coated in the slag I just mentioned, so you use your chipping hammer to chip it off if you want to restart the weld and continue it along, or you'll end up getting a slag inclusion where the two welds meet. Now this particular rod is called an E6013. Those numbers means it has pretty good penetration, but still a decent and smooth looking weld that's aesthetically nice looking when you're done. And it's 1/8 inch, so it welds best around 125 amps. and they're fairly cheap. If you want a rod that has less penetration, you're like doing thinner metal or metal that isn't as important to get penetration with, and you want a beautiful weld, get yourself 70-14 or 70-18 rods. If you want a high penetration rod for doing strong structural work, or frames that are thick enough, get yourself a 60-11. Now those aren't the only type of rods you can use. You can ask your welding supplier or look it up on a chart or a book what kind of rod may be most suitable for your application. It's very important not to let your rods get wet or damp, or this will start to happen. The coating will start to flake off, and it'll especially start to flake off as soon as you start to weld. Then your arc will all spatter and be horrible, and your rods will become useless. A very good place to store them is in a broken down fridge or freezer, because they've got a rubber sealer on the door and it keeps them very dry pretty much forever. One of the hardest techniques to get used to when you're arc welding is striking the arc. So when you've got your ground connection connected to your piece of metal, you have to sort of hold your rod, whatever position you find comfortable. Myself, I find near vertical or up to 45 degrees angle just fine, but you have to give it like little strikes where you actually touch the two pieces together, and the end is already cleaned a little bit to make that easy. And then as soon as it starts to arc, you have to hold it about 1/8 of an inch away and maintain that gap to keep the arc working properly and to have your weld turn out nice. And then while you're welding, you're zigzagging it or doing little curves like that. Now I'm going to show you how to strike an arc and how to just run a bead. Now remember, always wear something that covers all the skin on your body and a full face mask. Once the tip turns red hot, it starts to arc easily. Simple as that. Now it's a good idea to wait till the weld cools before you start chipping off the slag, because the slag is super hot. It'll stick to your eyes, melt your glasses, burn through your clothes, and when it gets cool, it just starts to flake off by itself. It makes like crinkling sounds. So, looks pretty decent. The slag came off no problem. Now most people think that stick welding or arc welding is more difficult. I guess I kind of have to agree. MIG welding or wire welding is more like using a hot glue gun, because the temperatures are a little bit lower and the blob or the molten blob of steel is a little bit less runny and easier to control, and there's no slag. But these welders work excellent outdoors in any amount of wind. They're so much cheaper to purchase. Sure, you do have to hook up 220 volts in most applications to make them work, but they're just so simple. They just need a bit more finesse in controlling the penetration so you don't burn through or have your molten blob just drip and fall off or something like that. And they work very well on materials that have a little bit of, coating or slag on them, even a bit of paint or a bit of rust. They seem to just go through that no